somewhere in the distant future, so distant that numbers barely mean anything anymore. The universe may end not with silence, and not with a collapse, but with a tear, not metaphorically, literally. Every galaxy, every star, every planet, and eventually every atom in existence could be ripped apart, piece by piece, in a runaway process that only accelerates with time. Physicists call it the Big Rip, and it's one of the most extreme, most violent theories ever proposed for how everything might end. Today, we're going to break down exactly how it would happen and why some scientists think it's more possible than you'd expect. To understand the Big Rip, you first need to understand dark energy, the strangest ingredient in the entire universe. In the late 1990s, astronomers were studying distant supernovae, expecting to confirm that the universe's expansion was slowing down under the pull of gravity. Instead, they found the opposite. The expansion was speeding up. Something was pushing galaxies apart faster and faster, working directly against gravity itself. Scientists gave this unknown force a name, dark energy, but to this day, nobody knows exactly what it is. What we do know is that it makes up roughly 68% of everything in the universe, far more than all the matter, stars, and galaxies combined. And it's not evenly distributed like matter. It appears to exist everywhere, in the fabric of space itself, growing stronger as space grows larger. This discovery was so significant that the astronomers behind it won the Nobel Prize in Physics in 2011. But it also opened up a disturbing question. If the force pushing the universe apart keeps getting stronger, what happens at the end of that process? Most models of dark energy assume it stays constant, a cosmological constant, that leads to a slow, cold, big freeze. But a small subset of models suggest something different. That dark energy could be a form of phantom energy, a version of dark energy so aggressive that its repulsive force actually increases in strength as the universe expands. And if that's true, the ending looks completely different and far more violent. If phantom energy is real, the Big Rip wouldn't happen all at once. It would unfold in stages, over an almost incomprehensible span of time, before accelerating into a final catastrophic instant. It would begin roughly tens of billions of years from now. Distant galaxies, already separated by unimaginable distances, would start to recede faster than the speed of light, not by moving through space, but because space itself would be expanding that quickly between them. One by one, galaxies would vanish from view, not because they exploded or disappeared, but because their light could no longer reach us. The night sky, over billions of years, would grow darker and emptier, until our own galaxy stood essentially alone in a visibly empty universe. That's just the beginning. As the expansion continues to accelerate, dark energy's repulsive force would eventually overpower gravity at smaller and smaller scales. First, it would overcome the gravity, holding galaxy clusters together. Galaxies that once orbited each other would be flung apart. Then, roughly 60 million years before the theoretical end, it would overpower the gravity holding individual galaxies together. The Milky Way itself would unravel, its hundreds of billions of stars scattering into the growing void. About 3 months before the end, the force would become strong enough to rip apart solar systems. Planets would be torn from their orbits around their stars, drifting off alone into an expanding, emptying universe. From here, things move impossibly fast. About 30 minutes before the end, the expansion would overpower the gravity holding planets themselves together. Earth, if it still existed in any form, would be torn apart, not by heat or explosion, but by space itself expanding faster than gravity could hold its matter together. In the final seconds, the same unraveling would happen to stars, then to asteroids, then to any solid object of any size. And in the last fraction of a second, literally 10 to the -19th seconds before the theoretical end, the expansion would become strong enough to overpower the electromagnetic force holding atoms together. Molecules would be torn apart, then atoms themselves. Then, according to the math, even the fundamental particles inside atoms would be ripped apart, dissolved into an expanding nothingness. At that point, the concept of matter would stop meaning anything at all. So, is this actually going to happen? Here's the honest answer. Probably not, but scientists can't rule it out. The Big Rip depends entirely on dark energy behaving like phantom energy with what's called an equation of state parameter below -1. Current measurements from missions studying the cosmic microwave background and supernova surveys suggest dark energies. Behavior is very close to a plane cosmological constant, meaning a big freeze is statistically more likely. But the margin of error in these measurements isn't zero. Some studies over the past several years have even found hints, not proof, but hints, that dark energy's strength might be evolving over time rather than staying perfectly constant. If future observations confirm that, the Big Rip moves from extreme edge case to a genuinely live possibility. It's worth comparing this to the other major endings physicists debate. The Big Freeze, or heat death, assumes dark energy stays constant, leading to a slow, cold fade into darkness over trillions of years, rather than a violent tearing. The Big Crunch assumes gravity eventually wins out over expansion, pulling everything back into a single point. But this would require dark energy to weaken or reverse, which current evidence doesn't support. Compared to those, the Big Rip is the most extreme scenario on the table, not because it's the most likely, but because it's the only one where the destruction reaches all the way down to the atomic and subatomic level. Whatever the truth is, none of this is something anyone alive today needs to worry about. Even the most aggressive Big Rip models place the event tens of billions of years in the future, roughly 7 times longer than the universe has existed so far. The sun will burn out. Human civilization, in any recognizable form, will almost certainly be long gone. But the fact that physics allows for an ending this specific, this mathematically precise, and this strange, says something remarkable about how much we've learned, and how much we still don't know about the force that makes up most of everything that exists. The Big Rip may never happen, but the fact that it's a real, mathematically valid possibility sitting quietly in the equations that describe our universe is one of the strangest ideas in modern cosmology. If you want to see how this theory compares side by side with the Big Freeze, Big Crunch, and vacuum decay, check out our full comparison video linked above. And if you found this one interesting, subscribe. We're covering the universe's biggest mysteries every week.